So this next section is a bonus section in Chapter 7. It's doing what's called coordinate proofs. It's kind of putting together some of the reasoning, some of the stuff from Section 7.6 and adding some algebra to it. I think you'll get the idea once we jump into some of the problems here. So let's take a look. So the first problem here is prove that the quadrilateral with these coordinates is a parallelogram. So the easiest way to do that is to graph it first. So L is -2, 3. M is 4, 3. N is 2, -2. O is -4, -2. And you want to prove that that's this shape right here is a parallelogram. So the best way to do this is probably just finding the slope of each of the sides and seeing if I have the same slope for these two sides and seeing if I have the same slope for these two sides. And so if I do the slopes, so if I do the slope of LM and I do the slope of ON, I find that I'm going to end up with 0 as my slope, right, because they're horizontal lines. And then if I check the slope of the diagonal ones, so the slope of LO and the slope of MN, I'm going to end up with 5/2 as the slopes there. So because I have, these are parallel and these are parallel, so that means I have two pairs opposite sides parallel, which means I have a parallelogram. Okay, so that's the main idea here. Let's try the next one. Prove that this is a parallelogram using midpoints. So if I'm doing midpoints, what I would do is, okay, this is -2, +2 here, and that's going to be A. B is 1, 4. B, C is 2, 8. C and D is -1, +6. D. And I'm trying to see if that is a parallelogram. So using midpoints, what I'm probably going to do here is I'm going to take a look at their diagonals. And I'm going to check to see if this and this, okay, share the exact same midpoint. Because if they do, then the diagonals would bisect each other. So check their midpoints. So the midpoint of DB ends up being 0, 5. And you're going to find out that the midpoint of AC is also 0, 5, which means that the diagonals bisect each other. Which means I have a parallelogram. Okay, let's try another one here. So prove that the quadrilateral with these coordinates, so let's go ahead and graph those. So M is 4, 1, I is 6, 4, K is 12, 0, okay, and 10, -3 is where E is. And you're checking to see if this is going to be a rectangle using slopes only. So what I'm going to do is take each of the sides, and if I can find the slope of this one and find the slope of this one, and I can find that their slopes are opposite reciprocals, I know that I would have a right angle here. So really I'm just going to check all the slopes and see if I have opposite reciprocals. So the slope of IK ends up being equal to the slope of ME, which is 4 over -6 or -2/3. And the slope of IM ends up being equal to the slope of KE, which means it's a parallelogram, so -3 over -2, or 3/2. Hopefully you can see here that when I did these slopes, these slopes, this one being 3/2 and this one being -2/3, are opposite reciprocals of each other, which means that this has got to be a right angle here. Also, this has got to be a right angle. These are all opposite reciprocal slopes. So that proves that you have 4 right angles. 4 right angles means it's a rectangle. And all I'm doing is I'm using the pathways from section 7.6, that first page with all the different pathways. How can we prove this rectangle using diagonals only? I can prove it's a parallelogram first, just like in problem number 2, using midpoints of the diagonals. Okay, if they coincide, then I know that the diagonals bisect each other, and then I can check using distance formula. I can check to see if they have congruent diagonals. And if I have this situation going on, so if I have a parallelogram with congruent diagonals, that means I have a rectangle. And again, I'm using one of the pathways from section 7.6. As a side note, the distance formula is d is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, just as a reminder from the beginning of the school year. Okay, let's jump to page 2. Okay, we're on the back side. The problem I want to get is problem number 6 here. It says that you're supposed to prove that the quadrilateral with these coordinates is not a rhombus, or is a rhombus, but it's not a square. So let's take a look at this. The first thing I need to do is identify if these are parallelograms. So let's graph it. 3, 2, C, 7, 0 is I, A is 11, positive 2, and 7, 4 is N. Okay, so first thing I have to do is identify if it's a parallelogram. So I'm going to go ahead and check their slopes. So the slope of NA is going to be equal to the slope of DI, which is equal to 2 over -4, which is equal to -1/2. Okay, you probably want to do each of these separately, so I would do something like this. The slope of DN is equal to 2 over 4, which is 1/2, and the slope of IA is also equal to 2 over 4, equal to 1/2. So these are the same slopes, these are the same slopes, which means these are parallel, and these are parallel, which means that you have a parallelogram. But we're supposed to show that it's not just a parallelogram, but that it's a rhombus, but it's not a square. So to show it's a rhombus, I just need to have perpendicular diagonals. And so I can do these two diagonals right there, and the slope of NI is going to be equal to 4 over 0, or no slope. And the slope of DA, I know, is a horizontal line, which has a slope of 0. That means that one's vertical and one's horizontal, which means I have perpendicular diagonals. So this plus this is going to give me a rhombus. But I want to see, as was mentioned earlier, that it's not a square. So I have to prove, keep in mind that a square is not only a rhombus, but it's a rectangle also. So I just need to show that it's not a rectangle. And so here's where I'm going to show that it's not a rectangle. I'll point this down here. These are not opposite reciprocal slopes. So no right angles. So it's not a rectangle. So therefore, because it's not a rectangle, it is not a square. But we did prove it's a rhombus. Okay, and that's basically the idea with these coordinate proofs. You have to mix in some algebra and show some of your reasoning here to indicate the things that you want to try to prove. Okay, I'm going to let you go ahead and try some problems on your own. Okay, good luck with it.